Hello dear students of the third secondary grade, and welcome to a new episode of our program. It's time for mathematics, and on this episode we'll be having a review on algebra. We'll be having some general examples on permutation and combination with our teacher of mathematics, Mr. Midhat Elisha, expert of mathematics at the Ministry of Education. Hello Mr. Midhat, and welcome to the program. I'm very glad to be with you today.
Thank you. And
all right,
I'm glad also.
Thank you very much, Mr. Midhat. Let us begin by reviewing some of the important rules of the previous episode.
Permutation and combination.
Yeah.
My dear, we have talked in previous episode about permutation, and we get combination, and now today we have to solve some of examples in permutation and combination. Firstly, we have some of laws in permutation and then in combination. First law, which is to find the value of NPR. And we know that NPR, it is equal to N multiply N minus 1 multiply N minus 2 up to N minus R plus 1. And we have two conditions must be satisfied. Condition number one, that N and R belong to Z positive integer, and also are less or equal to N, and are less or equal to N. This first. Second law, which is if R equal N, we get NPN, which called factorial N, and the factorial N equal N by N minus 1 by N minus 2 up to 3 by 2 by 1. And from this we have factorial N equals N factorial N minus 1, also equal N by N minus 1 factorial N minus 2, and so on. If we take N outside factorial, therefore it is A factorial N minus 1. Then it is equal N factorial N minus 1. Or N multiply N minus 1 factorial N minus 2, and so on. And the relation now between factorial and the permutation, that law is NPR is equal to factorial N over factorial N minus R. NPR equal factorial N over factorial N minus R, and as a result from this law, that in NP0 equal factorial 0, and each of them equals 1. This is the sum of laws of permutation. Again, NPR equal N multiply N minus 1, N minus 2 up to N minus R plus 1. And N and R belong to Z positive integers, and R less or equal to N. And NPN, when R equal N, then NPN called factorial N, it is equal to N multiply N minus 1, N minus 2 up to 3 by 2 by 1. And factorial N is equal to N factorial N minus 1, or N multiply N minus 1 factorial N minus 2, and so on. And the relation between permutation and factorial, that in NPR equal factorial N over factorial N minus R. As a result for this law, NP0 equal factorial 0 equals 1. This about the permutation. What about combination? About combination, that NCR it is equal to NPR over factorial R. This law used when N and R is integers or numbers. This first law and the condition is the same. N and R belong to Z positive and are less or equal to N. Number 2, we know that NPR, it is factorial N over factorial N minus R, then NCR equal factorial N over factorial R multiply factorial N minus R. This law used when N and R are numbers, simples, sorry. Number 3, it is NCR equal NC N minus R when we use this when R greater than half N. Like as 15C 14, it is 15C 14 from 15.1, it is 15C1. 15C7, it is C8 is equal to 15C 8 from 15 is 7 and so on. Number 3, this 1, 2, and 3, 4. If NCR equal NCH, therefore either R equal H or R plus H equals N. Number 5, the ratio, it is NCR over NCR minus 1, this equal to N minus R plus 1 over R. The law of ratio, but R and R minus 1 are consecutive numbers. And we use this as a law we have to prove this, that number 6, NCR plus NCR minus 1 equal N plus 1 CR, and use this in solving some of examples. And finally, we have NC0 equal NCN, and those are equal 1. This is the laws of combination.
All right, so now let us apply.
Mix up laws of combination and factorization.
Okay, so now we're going to apply these laws on the to the examples we're going to have right now. The first one says prove that NCR plus NCR plus 1 over NC1
over NCR
over NC1
CR
written here CR okay equals N plus 1 over R plus 1
this first
first let us do it first,
and then
hence find N if NC8
find N if
NC8 plus NC9 over NC8 equals 7 over 3.
7 over 3. My dear, this proof, now firstly, to prove that NCR plus NCR plus 1 over NCR equals N plus 1 over r plus 1. And hence use this as a law to find n if nc8 plus nc9 over nc8 must equal 7 over 3. Now, firstly, you have to get the proof. To get the proof, we take the left-hand side. NCR plus NCR plus 1 over NCR, and we put this, or we proved this as equal to n over plus 1 over r plus 1. Then we take left-hand side. Left-hand side equal NCR plus NCR plus 1 over NCR equal. We have divided NCR over NCR, this equal to 1, plus NCR plus 1 over NCR, we put this as a ratio. NCR plus 1 over NCR. This one plus. What about NCR plus 1 over NCR? The ratio between two consecutive combinations. Law number 5. It is NCR over NCR minus 1 equal n minus r plus 1 over r. Therefore, it is equal to n minus r. It is the greatest number of them. It is r plus 1 between bracket plus 1 n minus r plus 1 over r, which is r plus 1. This equal to 1 plus negative r, negative 1 cancelled with positive 1. Therefore, it is n minus r over r plus 1. Now, adding r plus 1, then common factor r plus 1. 1 is equal r plus 1 plus n minus r. Cancel the r with negative r. This equal to n plus 1 over r plus 1, which is right hand side. Prove that. Then we proved that the left hand side equal to the right hand side. Then بيقول بعد كده and hence find n if nc8 plus nc9 over nc8 equals 7 over 3. By using this, we can use this to prove the second part. NCR plus NCR plus 1 over NCR, it is equal to n plus 1 over r plus 1. And then NC8 plus NC9 over NC8, we can put this in the form n increased to n plus 1, and r plus 1, it is the greatest number. The greatest number of these three numbers, it is 9. Therefore, we can use that NC8 plus NC9 plus NC9 over NC8 equals 7 over 3. Use this to get n plus 1 over r plus 1. Then n plus 1 over r plus 1. R it is 8 and the r plus 1 it is 9. Therefore over 9 equals 7 over 3. Then cancel 3 with 9, it is equal to 3. Cross multiplication, we get that. Now n plus 1 equals 7 by 3. Then n plus 1 equal 7 by 3, it is 21. There finally n equal 20. This is the final answer, and the rule accepted because n is a positive integer. Okay, my dear? Do you understand? Thank you.
All right, so now let us have another example. This one says if NC8 multiplied by NC6
NC8
by
multiply NC6
is greater or equal to NC7 multiplied by NC5.
NC5.
So prove that N is greater than or equal 13.
N greater than or equal 13. This is the requirement. Look, my dear, NC8 multiply NC6 greater than or equal NC7 multiply NC5. هنا عاوزين يا ولادي نستعمل مجموعة القوانين بتاعتنا برضو. طب مجموعة القوانين في عندنا طريقة اعتقد ان دي هتبقى طويلة شوية. ايه رأيكم لو احنا عملنا expand بقى ل NC7 و NC8 و NC6 and cancel؟ لا تبقى كبيرة شوية. طب ما انا ممكن اعملها simplify. تعالوا نبص للارقام بتاعتنا NC8 NC6 NC7 NC5 8 6 7 5. من الفور نمبرز دول اقدر ان انا احاول استعمل قانون الريشيو. ازاي؟ by NC8 have NC7 we can divide it by NC7 and NC6 divided by NC5 or NC5 divided by NC6. يبقى اذا انا اقدر اقول له ايه؟ اقدر اجي في المسألة دي كده وهقول له بص يا ولادي اكتب ايه؟ هقول له divided both sides by NC7 multiply NC6. طيب تعالوا نشوف كده لما احنا عملنا الديفيجن هيبقى left hand side NC8 multiply NC6 over NC7 multiply NC6 greater than or equal NC7 by NC5 over NC7 by NC6. شوفوا كده يا ولادي طلع عندي ايه؟ طلع عندي we can cancel NC6 up and down from left hand side and NC7 from right hand side, and therefore we get now NC8 over NC7 NC8 over NC7 greater than or equal NC5 over NC6. ها يا ولاد ايه رأيكم بقى؟ بسطناها دلوقتي الى ابسط صورة ممكنة. تعالوا بقى نشوف الجزئية التانية. اصبح عندي NC8 over NC7 ratio between two combination and two consecutive. يبقى اقدر استعمل اللو بتاع الديفيجن. يبقى بالتالي هقول له it is equal to NC8 over NC7. It is n minus 7 8 plus 1 over 8 greater than or equal NC5 over NC6. The law but it is reciprocal. Then it is n minus 6 plus 1 over 6. Then it is equal negative 8 plus 1 n minus 7 over 8 greater than or equal 6 over n minus 5. We can cross multiplication, then n minus 7 by n minus 5 greater than or equal 6 by 8, it is 48. Brackets n square minus 7n 5 يبقى 12n plus 35 greater than or equal 48. Take 48 in other side بالنيجاتيف, then n square minus 12n minus 13 greater than or equal 0. And now we can factorize n square minus 12n minus 13 into n minus 13 by n plus 1 greater than or equal 0. Therefore, n greater than or equal 13 from n minus 13 greater than 0, and n plus 1 greater than 0, n greater than or equal negative 1. Since it is equal negative 1, therefore this solution is what? Yes, very good. Refused. Why? Because n is a negative integer now. N greater than or equal. Then maybe equal negative 1. And we say that n must be positive integer. Therefore, this solution is neglected. Therefore, the solution is n greater than or equal 13. This is the final answer. Do you understand, my dear? Thank you. شفت يا أولاد المسائل سلسة وبسيطة جدا وسهلة جدا ومعتمدة كلها أغلبها على إن إحنا يا مستر ياسر حافظين القوانين وإزاي how to apply these examples these laws.
tricks كده ساعات. بيبقى فيه tricks ساعات كده.
لكن التريكس دي تبقى ايه؟ يعني جايه من داخل المساله، لكن كبدايتها في الاول بتبقى مجموعه القوانين احنا حافظينها كويس، وبعدين كتر الحل هيعودنا على التريكس اللي زي كده في المساله.
اكيد طبعا. how to apply is what's important. Let us move to another example. This one says prove that NCR plus NCR plus 1 all right equals n plus 1 CR plus 1 all right. So then all right, let's have this first. We have two requirements here.
خلينا احنا الاول في البروف الاول بعدين ناخد الريكويرمنتس.
NCR plus N
prove that
NCR plus NCR plus 1 equals N plus 1 CR
plus 1
plus 1.
وبعدين في require number 1 require number 2.
The first requirement says prove that NCR plus 2N CR minus 1
NCR
plus 2NCR minus 1
NCR minus 1
plus NCR minus 2
plus NCR minus 2
equal N plus 2 CR.
plus 2 CR. Require number 2.
Requirement, the second requirement says solve the equation. Solve the equation. 17 CR
17 CR
plus 17 CR plus 1
R plus 1
over 17 CR plus 1
plus
17 CR plus 2 equals 7 over 12.
Equal 7 over 12. This is the example. Now we have to show the first. Take care, my dear. من ضمن القوانين بتاعة الكومبينيشن في عندنا القانون ده اللي هو NCR plus NCR plus 1 equal N plus 1 CR plus 1. بس الحقيقة هو عشان يديهوني في المسألة في الأول قال لي إيه؟ prove that this law and then find two requirements 1 and 2. يبقى احنا عايزين نعمل proof لللو وبعد كده نستخدم هذا اللو في ان احنا نعمل solving للتو requirements اللي عندنا. اوكي؟ فهنبدأ بالجزء الأول ان احنا هناخد left hand side NCR plus NCR plus 1. NCR plus NCR plus 1 equal. What about NCR? It is factorial N over factorial R factorial N minus R. We have to expand factorial by using simples, then بالفactorial طبعا, plus NCR plus 1, it is factorial N over factorial R plus 1, factorial difference between them, N minus R plus 1, it is minus R minus 1, N minus R minus 1. Numerator factorial N and factorial N, we can take factorial N common factor. But in denominator, factorial R and factorial R plus 1. Yes, we can put factorial R plus 1 as a factorial R. By taking R plus 1, it is R plus 1 factorial R. And factorial N minus R, factorial N minus R minus 1, also we can take N minus R, then it is factorial N minus R minus 1. Then it is factorial N over factorial R, take N minus R, factorial N minus R minus 1, plus factorial N, we can take factorial R plus 1 outside, it is R plus 1 factorial R, factorial N minus R minus 1. Now we have to take common factor from the numerator factorial N, from denominator factorial R, we can take factorial R common factor, and factorial N minus R minus 1. Then we have fraction factorial N, take the common factor, factorial R take N minus R minus 1, then it is 1 over N minus R, plus second fraction factorial N, take it common factor, factorial R N minus R minus 1, it is 1 over R plus 1. Now we have to adding two fractions, then the LCM of the two fractions, it is factorial, it is N minus R multiply R plus 1, then N minus R multiply R plus 1 divided N minus R, it is R plus 1. N minus R, multiply R plus 1 over R plus 1, then it is N minus R. Cancel minus R and the plus R up and down. Then final we get factorial N over factorial R, factorial N minus R minus 1 multiply N plus 1 over N minus R, R plus 1. Then we write this as factorial N, factorial R minus 1, factorial N minus R minus 1 multiply N plus 1 over N minus R over R plus 1. Then it is equal to what? My dear, look, we have N plus 1 multiply factorial N, then we can write this as factorial N plus 1. N plus 1 multiply factorial N, it is factorial n plus 1. Also, r plus 1 multiply factorial r, it is factorial r plus 1. And n minus r multiply factorial n minus r plus 1, it is equal to factorial n minus r. Then finally, factorial n plus 1 over factorial r plus 1 over factorial n minus r, which is the difference between them, this equal to now n plus 1 c r plus 1, which is right hand side. This is first. يبقى احنا وصلنا دلوقتي ان البروف بتاعنا ان NCR plus NCR minus 1 finally it is equal to N plus 1 CR plus 1. يعني عاوز اقول يا ولادي بصوا بقى معايا، عاوز اقول احنا قلنا هنا NCR plus NCR plus 1 equal N plus 1 CR plus 1. بصوا يا ولادي، having same N in left hand side, in right hand side it is equal to N plus 1، يبقى N increased by 1. في كمان ال R و R plus 1 بيتكتب عندنا ال greatest number of them which is R plus 1. يبقى by using this, if we have two combinations, one of them NCR plus NCR plus 1, it is equal to N plus 1, N increased by 1, and take the R is the greatest. ليه بنقول الكلام ده؟ عشان احنا كان عندنا two requirements. تعالوا نشوف، بصوا مع بعض كده. بصوا require number 1. Prove that NCR plus 2 NCR minus 1 plus NCR minus 2 equal N plus 2 CR. طب يلا نستخدم بقى الرول بتاعتنا كده. يلا هيبقى عندنا NCR proof number 1 NCR plus بدل 2 NCR plus 1 انا هكتبها كده NCR minus 1 plus NCR minus 1. بدل ما هو مديني 2 NCR minus 1 تبقى اكتبهم 2 fact combinations NCR minus 1 plus NCR minus 1 بعدين plus NCR minus 2. ليه يا مستر عملت كده؟ اقول لهم حبيت استخدم الرول بتاعتي، هستخدمها على الفيرست والسكند combinations وعلى الثيرد والفورث combination. في الفيرست والثيرد NCR plus NCR minus 1 اتفقنا ايه اللي بيحصل عندنا؟ اتفقنا ان ال N increased by 1 ويتكتب ال R greater than between them، يبقى على طول دي هتبقى equal N plus 1 N increased by 1 C greater of the two numbers it is R. ناخد الثيرد والفورث NCR minus 1 plus NCR minus 2 يبقى having same N وال R greatest بالاثنين، فيبقى بالتالي هتبقى N plus 1 C greatest R between them it is R minus 1. Also N plus 1 CR و N plus 1 CR minus 1 نستعمل اللو otherwise then again then N increased by 1 then N plus 2 C R numbers greatest number between them it is R then N plus 2 CR which is the right hand side. This is the first requirement of the two numbers. Second requirement, to solve the equation 17CR plus 17CR plus 1 plus 17CR plus 1 over 17CR plus 1 plus 17CR plus 2 equal 7 over 12. برضو نفس الفكرة، عندي في النيوميراتور 17CR plus 17CR plus 1, it is equal to what? It is equal 17 increased by 1, it is 18. C greater R between them, it is R plus 1 over 17CR plus 1 plus 17CR plus 2, then 17 increased by 1, it is 18. C greatest R between them, it is R plus 2. يبقى first أنا استعملت this rule، يبقى الرول اللي هو ادهاني دي as a given as a proof, and then or hence used this to solve equation or to prove another or and so on. Okay. كمل يا ولادي. 18CR plus 1 over 18CR plus 2. What is equal? It is the ratio between two consecutive combinations. Then it is equal to N 18 minus R. It is R plus 2 plus 1 over R plus 2 equal 7 over 12. Why used this? Because it is 18CR plus 2 greatest number in denominator, then 18CR plus 2 over 18CR plus 1. Then it is equal R plus 2 over 18 minus 2 plus 1, it is minus 1. Minus 1 from 18, it is 17 minus R equal 7 over 12. Cross multiplication, then 12R plus 12 by 2, 24 equal 7 by 17, 119 minus 7R. 7R. Now 12R minus 7R in other side positive 7R equal 119 and 24 in other side negative 24. Then 19R equal 95. Therefore finally R equal 95 over 19, it is equal to 5. Then R equal 5. This is the solution set of the equation of second requirement. ها يا ولادي، do you understand؟ شفتوا عملنا ايه في المسائل؟ بمنتهى السهولة، واعتقد مش محتاجة منكم كتير تعب كتير، كلها بس بسيطة. فكروا كويس وخلوا القوانين دي في دماغكم على طول. Okay? Thank you.
Okay, so far we've had three examples. Let us now move to the fourth one, which says if n plus 1 PR plus 1 equals n plus 1 CR plus 1 equals 5040, and n plus 1 CR equals n plus 1 CR minus 1,
equal 2 over 3.
To 3. So find R and N.
Find R and N. Firstly, if
n plus 1 PR plus 1.
N plus 1 PR plus 1.
2 N plus 1
N plus 1
CR plus 1.
CR plus 1
equals
5040. 5040.
And N plus 1 CR.
N plus 1 CR.
To M plus 1 CR minus 1.
To N plus 1 CR minus 1.
Equals 2 to 3.
2 to 3.
Find R and N.
Find R and N. My dear, he sees that n plus 1 PR plus 1 to n plus 1 CR plus 1 equal 5040. طيب ما أنا أقدر أفك ال n plus 1 بالpermutation. How? It is n plus 1 P R plus 1, which is over n plus 1 CR plus 1 equal 5040. We can expand n plus 1 CR plus 1 as n plus 1 PR plus 1 over n plus 1 PR plus 1 over or multiply factorial NPR over factorial R, which is R plus 1. This equal to 5040. We can cancel n plus 1 PR plus 1 up and down. Then factorial R plus 1 equal 5040. طيب وهنا بقى 5040. What is equal 5040 factorial R plus 1 equal 5040. Maybe we can use the calculator to find what is factorial equal 5040. The solution. Another solution I can't, or I haven't calculator now, but you can expand this number. We know that 5040 factorial, it takes to 1, then 1 divided by 1, 5040, divided by 2, 2520, divided by 3, 25 divided 3, 8, 12 divided 3, 4, 0, divided 4, 210, divided 5, it is 4, 2, divided 6 is 7, divided 7 is 1. يبقى أنا لو مش معايا الكالكوليتر دلوقتي ومش عارف أحسبها، طب بعمل إيه؟ أبدا، بسيطة جدا. معروف إن الفاكتوريال ده دايما بيوصل عندي الإيه؟ Yes, very good. بيوصل لل1. Therefore, we have to take 5040 as divided by 1, then divided by 2, divided by 3, divided by 4, up so on, until it came to 1. Then it is equal to 7 by 6 by 5 by 4 by 3 by 2 by 1. Then factorial R plus 1 equal this factorial 7, then R plus 1 equals 7. Finally, R equals 7 minus 1 equals 6. Then now we have to get R equals 6. Second requirement, it is n plus 1 CR to n plus 1 CR minus 1 equal 2 to 3. Substitute R equals 6, then n plus 1 C6 to n plus 1 C5 equal 2 to 3. This is the ratio between two consecutive combinations. Then it is equal to n plus 1, it is n plus 1, minus R, which is 6 greatest number, plus 1, over R, which is 6, equal 2 over 3. n plus 1 minus 6 يبقى n plus 4 minus 4 over 6 equal 2 over 3 cross multiplication, then 3n minus 3 by 4 12 equal 12. يبقى 3n equal 12 plus 12 24 divided by 3 by 3. Finally n equal 8. Then the solution now, that from first one we get r equal 6, from second one we get n equal 8. Okay my dear, do you understand؟ ها يا ولاد، خدتوا بالكم؟ شايفين قد ايه المسائل سهله؟ صدقوني كلها مسائل امتحانات، يعني من امتحانات سابقه كلها ومن كتاب المدرسه. اعتقد ان المسائل بتبقى سهله وما فيهاش اي صعوبه، وارجو ان انتوا تكونوا استوعبتم كويس قوي.
Okay, now let us have another example.
Yeah.
This one says if NPR
Yeah.
equals 120 multiplied by NCR,
Yeah.
then find the value of 12 C2R. Also find the minimum value of n, which makes this relation true.
is true. برضه example جميل قوي.
حلو بصراحة.
طيب نكتبه الأول كده. بيقول لنا if NPR equal 120 NCR and find 12 C2R and then find
the minimum value of n.
The minimum value of n,
which makes the
to
relation
make this
true.
relation is true. Firstly, we have NPR equal 120 NCR. يبقى NPR equal 120 NCR. يبقى NPR equal 120 NCR. We can expand this into NPR over factorial R. Then divided by 1 cross multiplication and cancel the NPR. Therefore, factorial R equals 120. Also again, factorial R equal 120. 120, ادي 120 divided by 1, it is 120, by 2 60, by 3 20, by 4 5, by 5 1. Therefore, it is factorial 5. Then R equal 5. This is the find the value of what? Then find 12C2R. 12C2R. It is 12C, 2 multiply 5, it is 10. And the simplifying by using simplification law, it is 12C, 10 from 12, it is 2. What about 12C2? It is 12P2, 12 by 11, factorial 2, 2 by 1, this equal 266. 12C2, C2R equals 66. And find the minimum value of n. خدوا بالكم يا أولادي من الجزئية دي بقى. Find the minimum value of n. We have now that NCR or NPR, and we find that R equal 5. Therefore, now we know that from the combination or permutation that condition R must less or equal to n, or n greater than or equal r. And r is 5, therefore n greater than or equal 5. And the minimum value of n is n equal 5. Minimum value n greater than or equal 5, then begins from 5, 5, 6, 7, and so on. Therefore, the least value of n, now it is n equal 5. Okay, my dear? Thank you.
All right, we don't have much time left, so we don't have time to have more examples. So could you please, before we wrap up the episode, tell us about or give us a general review on the most striking things we said during
هو
this
في
episode?
عندي example يعني أحب إن احنا نشوفه حتى ولو quickly كده.
Okay.
اللي هو كان number 9.
Number 9?
Yeah.
Okay.
Ah.
So can we do it very quickly? Because
بس
actually-
أنا يهمني الحقيقة إن أنا أشوف الإكزامبل ده.
All right.
Yeah.
This sound right looks long. I don't know.
لا بس هو السوليوشن بتاعه يبقى بسيط جدا.
Okay. So shall I read it? Is it
Yeah.
June 2010?
Yeah.
All right. It says if x is
ده كان في Egypt 2010.
yeah. Okay.
Yeah.
But we don't have much time left for that actually. Can we delay it
2010.
to the next episode?
Hmm?
Can we delay it to the next episode because we don't have time for it?
طيب okay.
Okay. I'm sorry, Mr. Midhat. I really wish I had had this example, but time is running up. And do you want to say just the few rules before we end this episode?
هو طبعا أهم حاجة كانت عندنا في موضوع هو كده الموضوع ده الكومبينيشن والبرميتيشن كده خلص تقريبا. احنا إن شاء الله النكست ابيسود هنشتغل في الباينوميال ثيورم. لكن في اللي احنا اشتغلناه سواء اشتغلنا permutation combination كان عندنا اول واهم condition that n and r must belong to z positive integer. دي اول حاجة. طلعت عندي بقى n في مرة fraction refused، r طلعت fraction او negative يبقى also refused. دي اول حاجة اعرفها. كمان عندي r must less or equal to n. r must less or equal to n. يبقى لو قلت r equal n يبقى n p n it is factorial n. لو قلت r equal n في الكومبينيشن ف n c n equals 1. n c n equals 1. لو n equal 0 or r equal 0 n c 0 also equal 1. اوكي. وطبعا بقى مجموعة القوانين التانية كلها احنا عرفناها. ولما بيديني في مسألة prove that we used this law to find another requirement. Okay, my dear? Thank you.
All right, and I'd like also to thank you very much, Mr. Midhat Elisha, for being with us and having this episode and this beautiful explanation. Thank you very much. And that brings us to the end of this episode. Dear students of the 3rd secondary grade, we've had throughout this episode some examples on
permutation.
Permutation and combination. We've had really some important examples of this lesson, and inshallah we'll be carrying on with more examples on the next episode. Don't forget to join our Facebook group مدرسة على الهواء ثانوي. This is our official group مدرسة على الهواء ثانوي, and until we meet you again inshallah, we wish you all the best. Goodbye.